Question number 5. To a nighttime observer on Earth, how many degrees do the stars appear to move around Polaris in 3 hours? Well, the first thing you need to know for this question is that Polaris is also known as the North Star. They love talking about Polaris, Polaris, Polaris. They will never say North Star, so you better know it. But the trick is simple math. We all know that a circle, or a sphere, like Earth, has 360 degrees, or 360 degrees around. We also know that there are 24 hours in a day. If you divide 360 by 24, you get 15 degrees per hour. So what you should know from here is that whether it's the sun rising and setting, it's moving 15 degrees an hour. The stars rotating around Polaris, it's 15 degrees per hour. So if we go back to our question, we see 3 hours. So let me just read it again, check it over. To a nighttime observer on Earth, how many degrees do stars appear to move around Polaris in 3 hours? Well, now that we know that Polaris is the North Star, and things are going to be rotating around up to 360 degrees around it in 3 hours, let me go back to my word site, do some of that math for you guys. 15 times 3 equals 45. Pretty easy, I know. Hopefully you guys can remember this. This 15 degrees is important. They usually ask a question about it. But obviously, you guys can tell that the answer to the question is going to be 45 degrees in 3 hours. Question number 6. To an observer in New York State, the duration of daylight increases continuously from. Now, the trick of this question is you need to know the longest day of the year and the shortest day of the year. The shortest day of the year, which unfortunately, if you see my calendar down at the bottom, it is 12/12/12 today. So we're getting closer and closer to the shortest day of the year, December 21st. That's the shortest day of the year. A lot of people don't like it because there's the least sunlight, but I always say from 21st on, we get more and more sunlight. Let's be an optimist sometimes, right? So, what we do know is that December 21st is the shortest day of the year, and then June 21st is going to be the longest day of the year. So to do this question, I always say that it's easiest to set up a mock timeline, as I have here. So on December 21st, we have the least daylight. On June 21st, we have the most, messed up there, most daylight. Let me fix that real quick. All right. So you have the most daylight on June 21st. Now, if you go back to the question, the trick of the question is if you plug these in, when is light going to increase the entire time? From December 1st to December 21st, the amount of light we're going to get will decrease. From December 21st to February 1st, it will increase. And although there's more increasing, it's not continuous. Remember, continuously. That's important to remember. The next, from September to November, we get less light every day. From June 1st to June 21st, we get more light. And then from June 21st to August 1st, we get less daylight. And the correct answer is 1. March 1st to May 1st, my birthday, we get more and more sunlight. So the trick is that when you take something like March to May, you could see, using the timeline, that March to May will fit, I don't know if I'm going to be able to do it for you, but March to May would fit right around this area to this area, maybe a little further. Okay, so you know it's going to fit on the timeline. It fits in between December 21st and June 21st.